All right, so this last lesson, we're going to be factoring special products. Special products consist of perfect square triangles, trinomials, I'm sorry, and a difference of two squares. You will learn others once you get to Algebra 2, but we're not going to worry about those since you're in Algebra 1. So our focus is perfect square trinomials and a difference of two perfect squares. We normally just say a difference of two squares. Now, I may break this lesson up into two different videos. If it gets to be really long, I'm going to make this part one, a part two, where I just work on perfect square trinomials in this video, and I may work on factoring the difference of two squares on the next video. But if I see I'm still making good time and I can get both of them covered, I'll just make this one video to cover both of them. So I'll just kind of play it by ear. All right, let's get started. We're going to recall something from the last unit which we were in when we got out of school in March, and it's a plus b squared. So if you take something and you multiply by itself, what do you think you normally get? Like if I take 5 and I multiply it by itself. Well, if I take 5 and multiply by itself, I'm going to get 25. Or if I take 8 and multiply by itself, I get 64. Or if I take 11 and multiply it by itself, I get 121. But notice all these numbers that I'm getting right here are called what? They're called perfect squares. Okay, 25 is a perfect square. 64 is a perfect square. 121 is a perfect square. All right, since you know that, anytime you multiply a number by itself, you get perfect squares. It works the same way for polynomials. Like this, a plus b is a binomial, okay? A binomial times itself, you're going to end up with a perfect square. So when you take a binomial and multiply by itself, a plus b times a plus b, you're going to end up with a perfect square trinomial. Hold on, guys. I'll be right back. All right, I'm back. Sorry about that. All right, so if I take a binomial and multiply by itself, I end up with a perfect square too. They're called perfect square trinomials. And let's just take a look at it, what a perfect square trinomial looks like. All right, so a plus b times a plus b. So what I would want to make sure that I did is use double distribution. Some of you may think, well, I could just use the FOIL method. I really don't care. You're going to end up with the same result. So I just took this binomial and broke it up, and I kept that one. So I did a, okay, let me put break up, because if I do the packet, somebody's not going to understand what I'm doing. Somebody may not. A times a is a squared. A times b is ab, and I put the imaginary 1 there. And then b times a, you can say ba, but I'm just going to keep it as ab. It doesn't matter whether you say b times a or a times b. It's like saying 2 times 3 is the same as 3 times 2. It doesn't matter. But I put mine in alphabetical order. Instead of ba, just go with ab. Put my imaginary 1. And then b times b is b squared, because remember, these are exponents of 1. And like right here, a times a was a to the second power. And when you multiply variables with the same base or like variables, add the exponents. So b times b is b squared. Now, these two middle terms are like terms. So when you have like terms, you can combine them. When you combine them, you do not change the exponent. So 1AB plus 1AB ends up being 2AB. Okay, so all I did was combine like terms. So that's how 1AB plus 1AB became 2AB. So that leaves me with, that tells me that A squared, A plus B squared is equal to A squared plus 2AB plus B squared. This whole thing is called a perfect square trinomial. So what does that mean? This whole thing right here is a perfect square trinomial. Let's examine each part of this. Okay, so A squared, where A squared is a perfect square because A times A gives you A squared. B squared is a perfect square. So the very first term in this trinomial is a perfect square. The very last term in this trinomial is a perfect square. Now let's take a look at the middle term. It says 2AB. Well, 2 means twice, okay, when it's mashed together like that. Twice the product of A and B, okay? So if I can find A and B and then multiply them and then multiply that by 2, it should fit this perfect square trinomial. The question is, how would you find A? So if I know A squared, do I automatically know A? So let's just say A squared. Let's say A squared is 9. Do you know A? You should. If A squared is 9, all you have to do is take the square root of both sides, so A is 3. Suppose B squared was 25. Well, would you know B? You should, because the square root of 25 is 5. So if you know A squared and B squared, it's very easy to figure out A and B, okay? All right, now, if you take A and B and multiply them, as this situation says, as the middle term says, multiply A and B, and then double it. 2 means double it. And you have all these conditions. This is called a perfect square trinomial. In other words, if your middle term is twice the square root of A squared times the square root of B squared, which is B, and your first and last terms are perfect square, it's automatically a perfect square trinomial. All right, so let's move up and see if we can look at some examples. No, I need to do the one with A minus B squared, because A minus B squared is still A minus B times A minus B. It's a binomial times itself too. All right, but let's take a look at what we have. It says a perfect square trinomial has first and last terms that are what? Perfect squares. We just talked about that. First term, last term, perfect squares. And the middle term is twice the product of the square root of the first and the square root of the last. What does product mean? Product means after you take the square root of the first term and the square root of the last term, you multiply it. And then it says you need to multiply it by 2. Twice means multiply by 2. And we'll get into what they look like in just a second. All right, but let's go on. You can also have A minus B squared. So instead of having a sum, you can have a difference. A minus B squared is simply A minus B times A minus B. All right, so if you want to figure out what kind of perfect square it produces, just multiply them. And you're going to end up with the perfect square trinomial. Trinomial 1, 2, 3. Okay, perfect square because you multiply the binomial by itself. Anytime you multiply something by itself, you get a perfect square. All right, so let's take a look at it. All right, so here I kept this, I broke this one up. Here I kept this one together. So I have A, so that's my A, and then negative B times all of this too, okay? So A times A minus B and negative B times A minus B. So A times A is A squared. A times B is negative AB, but notice I put an imaginary 1 in front of that negative AB. Excuse me. Negative B times A is negative 1AB. I put mine in order. I don't say BA, I say AB. All right, and then negative B times negative B is positive B squared. Okay, so if you combine like terms, you will see that negative 1ab is, and negative 1ab makes negative 2ab. All right, so a squared minus 2ab plus b squared is what I get if I multiply a minus b by itself. In other words, if I square a minus b, I end up with a squared minus 2ab plus b squared. This is also a perfect square trinomial. It is a result of me getting a binomial, of multiplying a binomial by itself. Okay? All right, now let's see if the same conditions hold true as did up here. Let's see if the same conditions hold true. All right. So it says a perfect square trinomial has the first and last terms that are perfect squares. And the middle term is twice the product of the square root of the first and last term. And I'm just going to put underneath here. Let me put this. Let's put first term and last term. Okay. All right. Now let's go back down. First and last term should be perfect squares. Well, a square is a perfect square. B square is a perfect square. All right, now keep in mind, anytime you square a number, you're always going to get a positive. So you would never see a negative or minus sign here or right there, okay? Because anytime you square something by itself, you get a positive. So if the first and last terms are perfect squares, we expect them to be positive, guys. So you would never see a minus here. Now notice that you see a minus here, whereas you didn't see it up here. You saw a plus, okay? It doesn't matter about the middle term. The middle term can be plus or minus, but the first and last terms will never be anything besides positives, because the first and last terms have to be perfect squares in a perfect square trinomial. Now, why is this a minus? Look at your sign here. Your sign, when you did a minus b times a minus b, was a minus. So the middle term is a minus. Okay, so the only difference between this perfect square trinomial and this one here is that the middle term went from a plus to a minus. Okay, now let's continue to see if this middle term fits the rule that it's twice the square root of the first term and the square root of the last term. What is the square root of a squared? Okay, the square root of a squared is simply a. The square root of b squared is simply b. So twice that product will be twice ab. Okay, and again, the middle sign doesn't matter. It's just the first and last terms have to be perfect squares, so they have to be positive, first and last. Middle term can be positive or negative. All right, so this fits the perfect square. This is a perfect square trinomial too, okay? All right, let me go over recall some more perfect squares just to make sure we all have it. 1, 4, 9, 16, 25, 36, 49, 64, 81, blah, 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 blah. All those are perfect squares because to get 1, you have to do 1 times 1. 4, 2 times 2. 3, 3 times 3. 16, 4 times 4. 25, 5 times 5. You all get the gist of it. To get a perfect square, you have to multiply something by itself. All right, perfect square variables have even exponents. Okay, this is something that you really need to know. A variable is considered as a perfect square as long as its exponent is even. Okay, so x squared is a perfect square because x times x will give you x squared. Y to the 6 is a perfect square. 6 is even. Y cubed times y cubed gives you y to the 6. S to the 6, 12th is a perfect square because s to the 6 times s to the 6 gives you s to the 12th. Remember, when you're multiplying powers with the same base, what do you do with these exponents? You add. 6 plus 6 gives you 12. 3 plus 3 gives you 6. An imaginary 1 plus an imaginary 1 gives you 2. M to the 4th is a perfect square because m squared times m squared gives you m to the 4th. N to the 18th is a perfect square. N to the 9th times n to the 9th gives you n to the 18th. You just add 9 plus 9 to get your 18 for your exponent. So keep in mind, if it's a perfect square variable, it has an even exponent. So if I ask you all, what is the, what, and if we'll say x to the 20th, if x to the 20th is a perfect square, you should be able to tell me yes, because it has an even exponent. If I ask you what two variables or powers you would multiply to get x to the 20th, you should be able to tell me that that's x to the 10th times x to the 10th. Excuse me. Because 10 plus 10 is what gives you 20. Okay? All right, let's move on. All right, so we know, again, a perfect square trinomial has the first and last terms that are what? Perfect square. So the first and last terms will always have a plus sign in front of them, or it will be understood that they are positive. And the middle term is twice the product of what? It's twice the product of the square root of the first term and the square root of the last term. Okay, so we're going to determine if the following trinomials are perfect square trinomials. So we got to see if it fits these rules right in here, okay? These rules right in there. All right, so I'm going to check to see if the first and last terms are perfect squares. First and last terms have to be perfect squares. So that's the first thing I'm going to check. All right, so let's take a look at it. All right, so here's the first term. That's first. That's middle. And this one is considered as my last. All right, so the first term is x squared perfect square, where it has an even exponent. Yes. Is 4 a perfect square? Yes. Okay, so I'm going to put x squared and 4 are perfect squares. Okay, now I need to check one more thing. I've checked the first and the last. Now I need to check the middle. Okay, so now what does it say about the middle? So if I go back up here and look again, well, the middle term has to be twice the product of the square root of the first term and the square root of the last term. All right, so here we go. I need to find the square root of the first term and the square root of the last term first, and then I can multiply by 2. Okay, so you're going to find the square root of the first and the square root of the last, and then multiply by 2 to check it. All right, so here we go. If I can go back to the hand and move it. Check the middle. What is the square root of x squared? Well, what number times itself gives you x squared? Or what power times itself gives you x squared? That will just be x times x. So the square root of x squared is x. What is the square root of 4? The square root of the last term. Okay, it's 2. Okay. But what does it say you could do? It says that the middle term has to be twice this product right here. That product is 2x. So basically, you're looking to see if 2 times 2x is 4x. And that's a yes. So the first term checks out, the last term checks out, the middle term checks out. And yes, this would be a perfect square trinomial. So you're just checking each one. All right, if you look at number 2, you're going to check the first and last terms. And let me make sure, right, I put right here, check first and last term. Okay, now we're going to check again. Check the first and last terms. They got to be perfect squares. Where is x squared perfect square? X squared and 49 are perfect squares. X squared has an even exponent. Automatically makes it perfect. Okay, they are perfect squares. Now I need to check the middle, okay? So I'm going to check the middle term. And I'm running out of room, so I'm going to check the middle term over here somewhere. All right, so what is the square root of x squared? X. What is the square root of 49? 7. Okay, so it just says that the middle term has to be twice this product, the product of those two square roots. So that product is 7 and x, okay? So the middle term has to be twice 7x, which is 14x. Does that check out? Yes. Now, I know somebody saying, well, that middle sign's minus. I don't care about the middle sign. The middle sign can be plus or minus. I just need to make sure that these two perfect squares are both positive. That's a plus, and that's an understood positive, okay? All right, so this is also a yes. All right, let's move on. All right, let's check this one. Okay, so I'm going to check the first and last terms on this one. All right, so here's number 3. What is 9x squared a perfect square? Well, 9 is a perfect square and x squared is a perfect square. So the whole thing is a perfect square. And automatically a positive 4 is a perfect square. So these are perfect squares. You're fine on the first and last terms. Then all you have to do is check the middle. Now, check the middle. Okay, so how do I check the middle term? All right, so this was first and last. That was. Okay, now check the middle. Okay, so to check the middle, you're going to take the square root of the first term. So the square root of 9x squared. Well, what's the square root of 9? 3. What's the square root of x squared? X. What is the square root of the last term? 4. With square root of 4 is 2. All it says is that the middle term has to be twice this product. Okay, what is that product? Well, 3x times 2x is 6x. So twice that, twice 6x would automatically be 12x. Okay, all right, but is this a 12x? Is the middle term a 12x? No. Okay, so is this a perfect square trinomial? Okay, not a perfect square trinomial. Had the middle term been 12x plus 12x, minus 12x, I would have been good to go, okay? I would have been fine. But it's just not, so don't worry about it. Could have been plus 12x or minus 12x. That's what messed it up, that negative 6x. Okay, now let's check number 4. All right, number 4. I need to make some separation here. All right, so let's check the first and last term. Nine x squared. 9x to the fourth is a perfect square. 9 is a perfect square. X to the fourth is a perfect square because it has an even exponent. Therefore, the whole thing is a perfect square. All right, and that's the last one is 16y squared. 16 is a perfect square, and y squared is a perfect square because y squared has the exponent 2. 2 is even. So both of these are perfect squares. Okay, so they check out. Okay, now I'm going to check the middle term. Okay, so now let's check the middle term. So after I check that, I check the middle. I really don't need that. I just do this right here. All right, so you do that first. Then you check that. Okay, let's check the middle. All right, so to check the middle, you take the square root of the first. The square root of 9 is 3, and the square root of x squared, x to the fourth is x squared. Basically, you just cut your 4 in half. All right, the square root of 16y squared. Well, the square root of 16 is 4, and the square root of y to the second power is just y. Basically, you just cut the 2 in half. Now, what the rule for the middle term says is that the middle term is twice this product right here. Okay, so what is that product? So let's get back to what that product is. So multiply to see that product. Okay, that product is 12x squared y. Okay, but it says the middle term is twice that, which means the middle term needs to be 12x, not 12, but 24. I'm sorry, guys. Undo. It needs to be 24x squared y. So is the middle term 24x squared y? No, the middle term is 24x to the 6y. So this is different from that. Okay? So this would be no, it's not a perfect square trinomial simply because that 6 is not a 2. So you just have to watch for little things like that. You have to make sure the exponents are the same. You have to make sure you don't these back here, these perfect squares don't have negatives or minus signs sitting in front of them. They don't have a negative sitting in front of it because perfect squares are never negative. All right, let's take a look at 5. All right, if you look at 5, I'm going to check the first and the last term. Okay, check first and last term. Okay, we're going to make sure they're perfect squares. 81 is a perfect square. X squared is a perfect square. So all of 81x squared is perfect. And of course, we know 25 is a perfect square. So these are perfect squares. Okay, now we're going to check the middle. All right, so if we check the middle term, we have to take the square root of the first. So the square root of 81x squared. Okay, the square root of 81 is 9. The square root of x squared is x. Just cut it in half, the 2 in half. All right, the square root of 25 is 5. All right, so what you want to do is check to see if the middle term is twice this product. Well, is the middle term twice that? So let's figure out what that product is. That product, 9x times 5 is 45x. But twice that would be, because I have to make sure it's twice that, 90x. Well, it checks out. So this would definitely be a yes, because the middle term is 90x. Okay, let's take a look at number 6. All right, so I'm going to take the first and last terms. So I'm going to say 4x to the 6th power. Okay, is 4 a perfect square? Yes. Is x to the 6th a perfect square? Yes, because 6 is an even exponent. As long as the variable has an even exponent, it's perfect square. So the whole thing, 4x to the 6th is a perfect square. And 9 is a perfect square, and y to the 4th is a perfect square along with it. So the first and last terms are perfect squares. Okay, now we need to check. Now, check what? Check the middle. So the middle term, to check the middle term, you take the square root of 4x to the 6th power. Square root of 4 is 2, and if you cut 6 in half, you end up with 3. Basically, that's how you find the square root of a variable term that's a perfect square. All right, the square root of 9y to the 4th. The square root of 9 is 3, and y to the 4th would be y to the 2nd. The square root of that would be y to the 2nd. Now, the rule says that if it's a perfect square trinomial, then your middle term is twice that product. So let's figure out what that product is. This product ends up being 6x cubed y squared. Okay, but the middle term should be twice that. Twice that is 12x cubed y squared. Okay, so is this the same as that? Okay. So this is also a no. Okay. It's not a perfect square trinomial. I had the x cubed and the y squared, but I didn't have the coefficient of 12. All right, let's move on. All right, I'm going to tell you something on 7 that automatically is a dead giveaway that it's a no. And you may already see it. So when I check x squared is a perfect square. But look at this. That's not 81. That's negative 81. What did I say about a perfect square? When you multiply a number by itself, you'll never get a negative. So I never get a negative 81. X squared is a perfect square. But not negative 81. Positive 81, sure. So automatically this is a no. Okay. Same thing is happening here. You see this? It's a negative 16. That's not a perfect square. Automatically that's a no. Doesn't matter whether your middle term is positive or it's negative. If this last term back here has a minus sign in front of it, you can't have a perfect square that's a negative. That will automatically be a no. All right, now, since we can determine whether it's a perfect square trinomial or not, let's actually factor some. Okay, so I want you to keep in mind, guys. Let's undo that. I'm not trying to move it. Factoring is when you work backwards. So what I'm going to do is I'm going to give you this so that you can give me that. Okay? I'm going to give you the polynomial and you're going to give me the factors. All right, here we go. Rules for factoring perfect square trinomials. All right, so factoring is going from, and I had it on this page, factoring is going from this to this or to that because if this is a perfect square trinomial, I multiply some binomial times itself. So I don't have to write it as x plus 3 times x plus 3. I could have written it as just x plus 3 squared. If you keep it as this, it'll be fine. Or if you write it as this, that'll be fine too, okay? All right, so here are the rules. All right, this is what we're going to do. We're going to take the square root of the first and last term. Okay, we're used to taking the square root of the first and last term because that's what we do to check it. And then we're going to write 2 binomial factors using the square roots from step A. So whatever you get from the square root of the first term and the square root of the last term will be used in your factors. What factors? Those binomial factors. They're going to be the same number, okay? It's either going to be plus or minus with these factors. So how do you know whether it's going to be plus or minus in that binomial factor? Make sure to keep the middle sign, not middle term, but middle sign from the given trinomial and use it when writing your binomial factors. So for instance, up here, what was the middle sign? Oh, it was a plus. Okay. I see the middle sign was a plus. Okay, what was the middle sign when I wrote my factors? A plus. If this middle sign had been a minus, then this would have been a minus. So basically, you match up, the middle term matches up with what's in your binomial factor. All right, so let's take a look at some. It says factor each polynomial, and I know some of you are looking at number 1, and you're like, wait a minute now. That looks like where I could use the x method because the leading coefficient is a 1. Okay, well, you can use the x method, but there's a shortcut on this one because this one is, and I'm telling you, all of these are perfect square trinomials. I made them like such. But look at this note. This note says you could factor using an x method for some of these. However, let's practice using the shortcut since these are all perfect square trinomials. So what do I mean shortcut? Okay. I know the x method is pretty short too. All right, these are perfect square trinomials. So what you're going to do is I want you to follow those rules or those little shortcuts I have at the top. So what is the square root? And if you look over here, I already have one done for you. What is the square root of x squared? The square root of x squared is x. Okay, because we're doing the first and the last term. The square root of 4 is 2. So all you do is use x and 2 in your factors. There's an X, there's a 2. There's an X, there's a 2. How do I know it's going to be an X and a 2 in both of them? Because this is a perfect square trinomial. And to get a perfect square trinomial, your binomials have to be exactly the same because it's a binomial times itself, or a number times itself, that produces a perfect what? A perfect square. All right, so these go inside of your factors. X plus 2 times x plus 2. Well, how did I know to put a plus sign? Well, what was up in the original polynomial or trinomial? In the original trinomial, in the middle term, it was a plus. So in the middle, I put a plus. Okay. All right, let's take a look at number 2. Then the reason I went or x plus 2 squared is because x plus 2 times x plus 2 is just x plus 2 squared. All right, let's take a look at number 2. Number 2, to factor a perfect square trinomial, you're going to take the square root of the first and the last. So what is the square root of x squared? Well, the square root of x squared is x. What is the square root of 49? The square root of 49 is 7. Okay, what is your middle sign? Your middle sign here is a minus. Okay, so you're simply going to write x minus 7 times x minus 7. Or you can write x minus 7 squared. Okay, boom, we're done. Okay, that's it. All right, let's take a look at 3. All right, you're going to take the square root of the first term. So the square root of the first term is square root of 9x squared. What is the square root of 9? 3. What is the square root of x squared? X. All you do to find the square root again of those exponents, those variable exponents, the variables with the exponents, is cut your exponent in half. Half of 2 is 1, so 3x. What is the square root of 16y squared? The square root of 16 is 4, and the square root of y squared is just y. Cut 2 in half, that's 1. You only have an imaginary 1 there, okay? You don't have to put the imaginary 1. I'm just showing you cut 2 in half, you get a 1. All right, now, what is the middle sign? Well, the middle sign in the original problem is a plus, okay? Now I need to go back right here. The original, okay? All right, so you're just going to use these square roots in your factors. 3x plus 4y. I don't like the way that's writing. 3x plus 4y times 3x plus 4y. Or you could simply write 3x plus 4y squared. You're done. These lessons, right now with these special products are really easy, and they're going to come in handy when you move on into upper level math classes because you can use shortcuts very quickly. It would be so hard to try to think of, oh, I need to factor this one by grouping, or by using the X method with the A times C. And who wants to multiply 81 times 25? I don't. All right, so let's just make sure we don't have GCFs because I failed to go over that. You're always supposed to be looking for a GCF first if you're trying to factor using any other technique besides using GCF. So if I say use a GCF to factor, then you're using a GCF anyway. But if I say use a shortcut to factor or an X to factor, then you need to be looking for a GCF. So let me come back to number 1. There was no GCF. All right, number 2, there was no GCF. Number 3, between 9, 24, and 16, there is no GCF. They don't all have an X. That's missing an X. And they don't all have a Y. These two have a Y, but that one doesn't. So there is no GCF. Let me go back and put something up here. And you probably need to go back and add this to your notes. Rules. The very first thing you need to do is look for a GCF first. Okay. So if I'm not telling you to factor using a GCF, then you look for the GCF on your own before you even start trying to use some kind of shortcut or X method or whatever. All right. So between 81, 90, and 25, well, there's nothing that can divide into all of those. And all of these don't have an X, so I don't have to worry about a GCF. Okay, so no GCF. So I can just proceed with finding the square root of the first term. So the square root of the first term is going to be 9. That doesn't look good. I think after a while, this Chromebook gets really tired. 81 x squared. I have to slow down. Square root of 81 is 9, and the square root of x squared is just x. Then what is the square root of 25? The square root of 25 is 5. Not minus 5, just 5. Okay, now what is your middle sign? Your middle sign is a plus. So you're going to use that when you write your factors. 9x plus 5 times 9x plus 5. Or you could write 9x plus 5 squared, and you're done. And that's just how you proceed with factoring perfect square trinomials. They're really easy, but you have to be able to recognize that it's a perfect square trinomial in order to factor it as a perfect square trinomial. All right, let's take a look at these last few. And I think what I'm going to do is split this up into 2 videos. Yeah, because I'm already at like 42 minutes. Okay, let's look at 5. You look at 5, no GCF amongst all 3 of those terms. So I'm just going to proceed with factoring this the way I would factor a perfect square trinomial. The square root of x squared is x. The square root of 9 is 3. My middle sign is a minus, okay? So I'm just going to write x minus 3 times x minus 3. Or I could write x minus 3 squared. And again, there was no GCF to begin with, okay? But take a look at number 6. I got 3, 12, and 12. Is there a GCF? Okay, sure, I see a GCF. So the GCF, and I'm going to call this the original GCF, is going to have a 3 as part of it. And then if you'll also notice, each one of them have an x. Okay, so each one of them have an x. Choose the x with the smallest exponent, so that would just be x, or x to the first. So your original GCF is 3x. So what do you always do with a GCF? Well, you always divide. So you're going to go through, in other words, you're going to try to make this smaller. You're reducing it. Divide by 3x. Divide each term by 3x. Divide each term by 3x. All right, so these will cancel, and x cubed minus x is x squared. Negative 12 divided by 3 is negative 4. 2 minus 1 is just x to the first. These are exact matches. They're going to cancel. Let me do them in a different color. All right, they'll cancel. And then 12 divided by 3 is 4. This is called your remainder. Remember in the last lesson, I said you always have to check your remainder to see if you can do what with it? Factor it. If you use a GCF, so did we use a GCF to start off with? Yeah, we did. So now, always check your remainder if you have an original GCF. I'm going to make that little note again. When I say check it, I mean check it to see if it can be factored, okay? Can this be factored? X squared minus 4x plus 4. Here's my remainder. Can that be factored? Okay. All right. So, yes, x squared minus 4x plus 4, I can use the x method on that, the simple one where you only had c at the top instead of multiplying a times c. Or I could look at this and say, oh, it's a perfect square trinomial because this is a perfect square, that's a perfect square. The square root of x squared is x, square root of 4 is 2. The product of x and 2 is 2x, but if I double 2x, I get that 4 in the middle. So I know it's a perfect square trinomial. So what I'm going to do is factor it using the shortcut. What is the square root of x squared? The square root of x squared is x. What is the square root of 4? The square root of 4 is 2. What is the middle sign? The middle sign is a minus. So I can write this as x minus 2 times x minus 2. But what do you always do with the original GCF? Okay, so the original GCF has to sit in the front. So you're going to bring that all the way down. So this is going to be 3x times x minus 2 times x minus 2. Or you can write this as 3x times x minus 2 to the second power. Okay? All right. Let's move on and look at 7 and 8. And that's it. We'll stop that lesson, and then I'll pick back up with a difference, factoring the difference of two perfect squares. It's much easier than this. All right, we're going to look for a GCF. Is that GCF between 7, 21, and 28? Okay, everybody should see it. Your original GCF. Okay, I can tell when this has been running too long because it starts to like lag very badly. All right, the original GCF, I'm trying to write slower. Equals 7. 7's part of it. What else is part of it? Because they each contain an x. Which one of those has the smallest exponent? That would be x cubed. So what do you always do with a GCF? Well, you always divide. So I'm going to divide each term by 7x cubed. All right, so you're going to end up with x squared plus 3x. These will cancel. Minus 4. Okay? All right, so I'm going to check it to see if it's a perfect square trinomial. The square root of x squared is x. Excuse me, I don't want to do that right now. To check it, I need to make sure that the first and last are perfect squares. Okay, so look at the first term here. The first term here is x squared. Okay, look at the last. Is this a perfect square? Keep in mind, if it's a perfect square, you'll never have a what? Okay, some of you all have it. I know you do. You never have a minus. So because this is a minus 4 and not a plus 4, I'm not even going to continue to check it to see if it's a perfect square. Okay, so if it's not a perfect square trinomial, what else have we learned to do if the leading coefficient was a 1 and it was a trinomial? So I'm just checking to see if you can go back and pick up other things. If the leading coefficient is a 1 and this is a trinomial, you should be able to use the x method. Not the x method where you multiply a times c, but just where you have c and b here. And these two numbers are used, these two numbers on the side are used in my actual factors. Okay, so a is 1, b is 3, and c is negative 4. I'm going to put the negative 4 here and the 3 there. So I need to say, okay, if I have a negative 4, then two numbers that I multiplied gave me a negative 4. So that means a positive times some negative gave me a negative 4. Okay, but how do I know if the larger number is positive or negative. Look down here. That's a positive 3. So the larger number is positive. All right. Now, with that being said, I know that 4 times negative 1 equals negative 4. And 4 plus negative 1 equals 3. I put this problem on here because I wanted to see if you are determining whether or not these are perfect square trinomials, and also if you could switch gears and go back to a previous lesson and use what we've learned. Okay, so what goes in the sides of the x? Negative 4 and 3. You do not need to use those numbers on the sides of the x, which are these, to rewrite the middle. Okay, anybody know why we don't need to use the numbers on the sides of the x to rewrite the middle? Okay, look at your leading coefficient. Your leading coefficient is a 1. The only time you use the numbers on the sides of the x to rewrite the middle is when your leading coefficient is something other than a 1. When your leading coefficient is a 1, you can simply use these numbers on the sides of the x in the actual factors. So you can write x minus 4 times x plus 3. But I'm not done because I had an original GCF. So the original GCF is 7x cubed. Now I'm done. Okay. All of this is now completely factored. All right, let's look at the last one, which is 8. And then we'll do one more video. But I won't put it all with this, okay? Because this is a lot to watch. This is like being in class for the whole hour. All right, now let's see if we have a greatest common factor between 9, 24, and 16. Will they all divide by anything besides 1? No. All right, do all of them have p's? No. 16 q to the 4th doesn't. Do all of them have q's? No. 9p squared doesn't have a q. Okay, so I don't have an original GCF in 8. I can just start. Now look, 9p squared is a perfect square. 16q to the 4th is a perfect square. And if I wanted to check the middle, I'm going to put 9p squared and 16q to the 4th are perfect squares. My goodness. And then the middle, for the middle term, if I check it, I take the square root of 9p squared, which is just 3p. Then I take the square root of 16q to the 4th, which is just 4p squared. Okay. I'm just trying to write equal to 4q squared. That's all I want to do. Okay, now to check the middle term, remember that this, let me go here. The middle term has to be twice this product. Okay, so what is this product? All right, so this product is actually 12p q squared, but twice that means it should actually be 24p q squared. So does it check out? Yeah, it checks out. Okay, there's my 24p squared. So all I have to do is take the square root of the first. So the square root, I'm going to go up here and work it. Let me go back down here. So the square root of 9p squared is 3p again. Okay. And I don't need to do that again. I have them right here. That's just a waste of pencil lead if I do it. All right, so I'm going to go back right here. I just need the middle sign. because right here I have the square root of the first and the square root of the last. I got them. The square root of the first is 3p. The square root of the last is 4q squared. All I need now is the middle sign. Well, what is the middle sign? The middle sign is a minus. Okay, so there's my middle sign. So I'm going to write 3p minus 4q squared times 3p minus 4q squared. Or I could simply write 3p minus 4q squared all squared. Okay, two of them. Okay, does that make sense? Just make sure you get the middle sign. All right, and that's that. One more lesson, and that'll be it for your 8th grade year. You did miss a whole unit on solving quadratics. So, I hope your teacher next year goes through it, all right?